The objective of this challenge was to build a pendulum whose pivot was not located nor at the center of mass or at the extreme, and we had to calculate theoretically the center of mass, the inertia, and the theoretical period, and also as well the experimentally calculate the period.
Here we can observe Javier building the model. He's working on the base. And here we can observe Mark. He's accommodating the stick to the sphere. Here we can see the pivot points, which is our pen. And yes, it works.
Here we have our complex physical pendulum that is made up by a pen, which is our stick, our length. We chose a golf ball, a plastic golf ball for the mass. And our pivot is a ruler, and this is a complex pendulum because the pivot is neither on the extreme or at the center of the mass.
In order to calculate the total moment of inertia, we first had to calculate the moment of inertia of the stick, which in this case is the pen, and then calculate the moment of inertia of the ruler, and then add them up. To calculate the center of mass, we use the following formula. Mass of the stick times the length of the stick over 2 plus mass of the ball times the length plus its radius, and all of that over mass of the stick plus mass of the ball. Finally, to calculate the period, we use the following formula. 2 pi times square root of inertia over sum of torques. Sum of torques can be calculated by the formula mass times gravity times distance times sine of theta, and theta we use 75 degrees.
To find the experimental period, we use the app Video Physics, and to analyze it, we use the graphs, in which we saw that the experimental period was 0.8 seconds.
We obtained an error of 17.83%, and we believe that this error was because we didn't take into consideration the friction when doing the pendulum, as well as our system that might have influenced in the error percentage.
Another source of error could also be air resistance, because we did not put the system in an enclosed ambient.
Okay, so some real-life examples of a pendulum could be a swing,
As well as a plumb line used by builders to obtain the true vertical measurement.
And another one that we can observe with musicians are metronomes, which are used to keep a steady pace and follow the beat.
In conclusion, the objective was fulfilled because we were able to build a physical complex pendulum which was not at neither the extreme or the center of mass, and we were able to calculate theoretically the center of mass, inertia, and period, and then by use of video physics we were able to find experimentally the period.
Vertical measurements and a metrometer that is used by musicians to keep the pace during their musical performance.
It's the motherfucking Eagle Double G.